Hello everyone, my name is Lucy Pan. I am the president of the University of Southern California Recumbent Vehicle Design Team. We represent vehicle number 26, nicknamed the Komodo. This year, the USC Recumbent Vehicle Team primarily aimed to take the quad concept from the 2019 competition to the next level. By improving upon the challenges and weaknesses of the vehicle and implementing newly designed subsystems, we are hoping to build upon the successes of last year's performance. A few challenges we faced in the previous design iteration was largely surrounding the implementation of smaller subsystems and human integration. To accomplish this, we redesigned the differential, created a more efficient seat design for rider changes, thought a lot about human integration for the steering system, and focused on building and integrating the fairing. We also had to consider the size of all our components to ship across the country since this was our first competition with this much travel.
One of the biggest problems we faced in the 2019 competition was with the drivetrain. And so there were a couple of things we needed to fix for this situation. One of the things we did was look at the rear triangle and make it mimic that of a bicycle, just so that we could get the bike parts geometry to fit more correctly. And what was happening before with the mid-drive is that as we cranked really hard on the pedals, it would pull the mid-drive askew and pop the chains off. But with our current design with the rear triangle, we included some dropouts so that we can include chain tensioners as well. And these chain tensioners will allow us to keep that, that torsion from happening on the mid-drive. And if we move on, one of the other problems that we faced was with the differential. And the differential is designed with two different free wheels along the same axis. And when you pull along the housing that you see here, one of the free wheels will be activated against the axle it's attached to, or both, depending on the movement and speed of rotation of each axle. And last year, there was nothing restraining this from moving in the translational direction. And so what we did was took cup and cone bearings from an Ashtabula crankset and threaded them onto our axles so that the axles are actually fixed within the frame. And this reduced much of the torque that was placed on the differential from before.
Inspired by Utah Trikes, we made our own differential using Formlab's clear resin for better strength of the casing.
For the seat design, our main goal was to design and implement a hammock-style hanging seat as a sort of novel concept, as opposed to the regular bicycle seat. However, we did also adapt the seat we used last year, a normal recumbent vehicle seat, to the current frame as contingency.
The main goal of the hammock seat was to keep it light and to make sure that it was easy to adjust. We were also planning on making multiple seats to accommodate the heights of the different riders. While at first the design seemed unlikely to succeed, when prototyping and testing the seat, it was fairly comfortable and was able to hold a lot of weight.
And this allows for easier removal and adjustment of the positioning. For the seat adaptation, it consists of two sliding aluminum brackets, one on the bottom to support the weight and one on the side with a double pin to fix the rotation of the seat in a certain place.
In terms of the steering design of our vehicle for this year, we decided to aim ourselves towards two goals. One was to increase the adjustability for varying riders, which meant that we wanted to be able to create a steering system that was easily changeable to fit each rider's needs that they were wanting. So like making sure the steering columns weren't too long for a rider, making sure they were at the proper angles so that riders could fit inside the vehicle comfortably. And that was one of our downfalls of last year's vehicle. So we decided to improve upon that. And secondly, we wanted to just make a more intuitive style steering. And in order to do this, we implemented a few design changes. So this year's vehicle's steering design includes a housing box that was created with an angle so that you could adjust the angle at which the steering column sits. And inside of it, there was an angular adjustment piece that we designed that fit a U-joint, which then connected to a pitman arm. And the U-joint allowed for the angular adjustment of the steering column while maintaining the pitman arm's location so that that geometry down there wouldn't change because it was in control of the steering knuckles.
As discussed before, one of our goals this year was to design and build a fairing in order to aid in aerodynamics for the sprint event, as well as offer general rider protection. To tackle this, we started with an initial bullet-style shape with a known drag coefficient and modified it to fit the unique contours of our vehicle. Our goal was to create and maintain smooth surfaces to direct air and lower the vehicle's coefficient of drag. The fairing is secured to the bike with captive quarter-turn fasteners that, when released, allow the fairing to pivot forward to allow easy access in and out of the vehicle.